Good morning.
Good morning.
Good morning.
Good morning.
So, how's everyone feeling today?
Good.
All right, feeling like it's almost Friday? All right, let's see who's here. Okay. All right, so let's see. We have everyone there in Joseph City? Yeah? All right, how about Holbrook? Are we missing anybody in Holbrook?
Hannah and Naomi Bateman.
Okay, so let's see. Hannah actually told me she was going to be. Okay, so Hannah, Naomi,
And Andres.
and Andres. Andres also told me he was going to be gone. So, again, remember, if you're out for any reason, I would recommend you watch the video. But, when we post it, if you're out for a school absence and you watch the video and let me know, then you get those points back. Okay? So, because, it's a school thing. So, okay, so before we get started today, I'm curious to know if anyone did anything amazing over the break.
I went to Disneyland on Christmas.
Disneyland, that's pretty amazing. So what was your favorite ride?
The Incredibles.
The Incredibles. Now, see, I didn't ride that. Was that in the California part?
A California Adventure. Yeah.
Yeah. Okay. Yeah, I need to. We need to go back, Jill, and do the California Adventure part. So, anyway, very cool. I want to go back with the. Has anybody else been to the Star Wars part, the Galaxy's Edge? Anybody done that? Couple of nods. Is that awesome, or is it kind of a waste?
It's really good.
It's really good.
Yeah.
Cool. All right. Anybody else do anything amazing?
I turned 16.
Hey, that's pretty good. That's pretty good. So, that's pretty awesome. I love birthdays. So, anybody else have a birthday over the break? All right. What else? Anybody else do anything amazing?
Oh, I moved to a new house.
Oh, that's pretty good. It's nice to decrease the number of homeless people in the world. That's awesome. No, that's a new house. That's great. So, so do you have like your own movie theater in your house and all that kind of stuff?
My room is my own movie theater.
Nice. That's awesome. That's great. Anybody else? Let's see. I thought of something. Oh, I know. Over break, I did play the role of Santa a couple of times. Some of you even saw me in Joseph City, so that was pretty cool. I think everybody at one point in time in their life ought to have little kids look at them with that much love. I mean, it's so exciting to go into a room and have everybody so thrilled to see you. Unfortunately, I don't get that all the time, but it's nice at that time. So anyway, all right. Well, okay, so the first thing we want to do before we jump into the lesson is, I know you were all disappointed that I didn't unveil this on Tuesday, but there we have the wheel of anxiety, or destiny, or whatever you want to call it. So what I want you to do is look for your name, make sure you see it, and make sure that it's spelled correctly. Okay? Because I hate it when people misspell my name. So, did I make any mistakes, or anybody go by?
Taylor isn't in this class anymore.
I'm not sure it's Rebecca.
Yeah, Taylor and Rebecca aren't in this class anymore.
Wait. I thought I replaced Rebecca. Okay, what have I done here?
Did she fail?
Oh, there's a Taylor. There's a Taylor in Hopi.
Mr. Strong?
Oh, I'm looking at the wrong class. That's the problem. Okay, hold up.
What?
Yeah, no, I'm.
Hopi.
I hope I didn't add some names that aren't there. Let's see. Yeah, no, I was looking at the wrong thing. Okay, so let's see. Where's Madison? Yeah, okay. So, yeah, this should be. Yeah, so Taylor's not there. I don't know why. I could have sworn I took Rebecca off. Maybe I didn't save it after that point. Okay. Wait. Okay. All right. Okay, so Rebecca shouldn't be on there. I guess I better double check. Is there anybody whose name is not on there? Here, let me scroll back up. Is there anybody else? So I'll take Rebecca off. Let's see, I got Cabri on there. Let's see. You put Sari on there. C22. So let's see if I take Rebecca off. I have the little randomization there. Okay, so now is everybody on there? Oops. Okay. All right, I'm going to have to monkey with it just a little bit, but I think that's pretty much it. Okay? All right, well, let's go ahead and get started. So we are back into 6.1, and this is where we left off. So let's switch to, okay. All right. Okay, so we were talking about degree measure, and so we were in the Babylonians and all that, and so they were the ones that came up with the measurement of time as well as degrees, and so they used hours, minutes, and seconds, and degrees, minutes, and seconds. So just like 1 hour is 60 minutes and 1 minute is 60 seconds, when you go to degree measure, 1 degree is 60 minutes and 1 minute is 60 seconds. So we did this yesterday. 1 degree is how many seconds then? How many seconds are in
3,600.
3,600. Okay. So, now, okay, so when the symbols that we use, okay, so for degrees, minutes, and seconds, okay, that we use the circle for degree, and then the minute is like 1 little tick mark, and the seconds are 2 little tick marks, okay? Whereas degree decimal, you'll have like 23.375 degrees. So there's 2 ways to express your degrees in more accurately. It's degree decimal or in degrees, minutes, seconds. So degrees, minutes, seconds, we usually just abbreviate that as DMS. And so then you write that as the degrees, then the minutes with the 1 tick, and then the seconds with the 2 ticks. Okay? All right, so now let's talk about how to convert it. So let's start with, let's say we have DMS, and we're going to convert that to degree decimal. Okay? All right. So here we have 54 degrees, 45 minutes. Okay. So what you do is, because there's 60 minutes in 1 degree, if you take your minutes and divide by 60, then that decimal part becomes your degree decimal. Okay. And so it's 54.75 degrees. Okay. Now, the way that you can do this on the calculator is if you take, let's see, where did my calculator go? So you might want to grab your calculators if you don't have one, because we're going to be using them here today. Okay. So if you have 54 degrees, so you type that in, 54, and then degrees. Well, actually, okay, let me before we start in here, let me just say that whenever we work with degrees, we want to make sure that we're in degree mode on the calculator. So if we press mode and make sure that, see, coming down here where it's in radians, we're going to deal with radians in just a minute. But right now, we want our answer in degrees. So we highlight degrees and press enter. Okay, now let's go back. So now we say 54 degrees. So the degree symbol is found in the angle menu on the calculator. So the angle menu is second apps. So second apps is angle. And so the highlighted number 1 is degrees. So you just press enter and then pops up 54 degrees. So then to do 45 minutes, we do 45 minutes. The minute symbol is also in the angle menu. So you do second apps, and then the 1 tick mark, that's the second option. And so that's 54 minutes. Now, if we have seconds, the way you put that in is with the double ticks. And so here I'm going to, just to have you practice on the calculator, I'm going to do 0 seconds. Now, the seconds, the double tick marks look like quotation marks. And so instead of with the alpha menu, those are with, instead of the angle menu, those are with the alpha keys. Okay, like when you're typing words on the calculator. And so the double tick mark, the quotation marks, are actually found above the plus sign. So it's an alpha key. So you press alpha plus, and that gives you your double tick marks or your quotation marks. And then you press enter, and so it converts it to a decimal. Now, really and truly, it's probably just easier to do it 54 plus 45 divided by 60. But I just want you to be able to use your calculator if you can. So what I would like you to do is that first practice problem on 1B, that first problem, go ahead and do that. And so if you have seconds, then let's see, let's add that in. So if you had seconds, you'd be plus whatever the seconds, and it's divided by 3600. Okay, so that's kind of how you do it by hand. This is how you put it in with the angle menu, the degree symbols. So go ahead and do that first problem there. All right, so Madison, when you've got the answer, let us know.
Madison left.
Choose what?
Madison left to go take cap and gown pictures.
Yeah.
Oh, okay. All right, thank you. All right, let's try. Kinsley.
$35.337.
Okay, very good. Now this brings up an important idea. Remember, in calculus, typically you're going to take all your computations out to 3 decimal places. So if you truncate it, that means just cut it off. If you cut it off, then it's 35.337 degrees. Okay. Now, if you round it, then usually if it's 5 or higher, you would round up. And so 35.338 degrees. And so I would accept either of those as perfectly right answer. And I would never, unlike a multiple choice thing, I would never have both of them. You just, one or the other is good. Okay? All right, any questions on that? Anyone need me to go through the calculator steps again? Okay. Okay, so now let's go back the other way. So we're in degree decimal. We want to convert this to DMS. All right. Now, the thing is that 240 degrees is going to be 240 degrees. That part you don't have to convert. I mean, that's just degrees. So what you have to convert is the decimal part. And so here, what you're going to do is multiply by 60. And then, so that would be 36. So the answer would be 240 degrees, 36 minutes. Now, when you multiply, if you still have a decimal, then you'd multiply by 60 again, and that would give you seconds. Okay? All right, now, so let me show you how to do this on the calculator as well. So here, what you do is you enter in 240.6 and then the degrees. So second angle, degrees. All right, and then when you do second angle again, if the option 4 converts it for you to DMS. So that's kind of sweet. Is that you don't have to multiply anything. You just press convert to DMS and then you press enter. And so then it gives you 240 degrees, 36 minutes, 0 seconds. Okay? Oops. All right, so go ahead and try the next problem, please. All right, Sierra, when you've got it.
I got 20 degrees, 7 minutes, and 30 seconds.
Okay, so 20 degrees, 7 minutes, and 30 seconds. Very good. Okay, whoops. Any questions on that? Anybody need me to go through it on the calculator? Yes? Okay. So again, on the calculator, you're going to just type in the original problem. So 20.125 degrees. So to get the degree symbol, it's second angle, degrees. Okay, now to convert to DMS, you do second angle, and then option 4, that little triangle there, that means convert that to DMS. And then we press enter, and boom.
Okay, one question. So how did you get the convert it to DMS? I got lost.
So do second angle,
Degree sign.
the degree sign, and then do second angle again
Okay.
to go to, and it's option 4.
All right, I see it. Thank you.
You bet. All right, any other questions? Okay.
So on my calculator, it says 0 degrees, 20 minutes, and 4.491 seconds.
Okay.
Nice.
So did you type in the degree symbol here?
Yes.
Are you in degree mode?
Now I am.
Okay. All right. So now just press enter. Do degree mode and then press
Okay.
enter again.
It works now.
All right. Okay. Any other questions? Okay. All right, so now we're going to talk about radians. Okay, now radian is just another way of measuring angles. Just like you can measure distance in feet or meters, and you can measure volume in gallons or liters, you can measure angles in degrees or radians. Okay, and now we usually use theta to be the unknown angle. And so the measure of angle is often measured in radians, or in rad is kind of the abbreviation. We'll actually talk about that a little bit. Okay? So visually what a radian is it's the arc length, the part of the circle that's the same distance as the radius of the circle. So yesterday or Tuesday, when Lauren said that the radian maybe had something to do with the radius, she was absolutely right. Okay, so if you imagine like a string that's measuring this distance, the radius, and you take that string on the outside of the circle, that distance is the same. 1 radian in any circle. Okay, now it used to be that trig in geometry was taught a lot more with circles. And so they would talk about the central angle being the same thing as the intercepted arc. I don't know if any of you remember that from geometry, but that's the angle that we're looking at. Okay. Now, when we do a complete circle all the way around, that's 360 degrees. Well, that distance in radians is 2 pi. 2 pi radians. We'll talk about that in just a little bit. But the actual conversion factor that I want you to know, to write it down somewhere on your sheet, is that 180 degrees is pi radians. Okay? We're going to use that in some problems coming up. So 180 degrees is pi radians. Okay, so now the notes. So a full revolution counterclockwise around a circle corresponds to 360 degrees or 2 pi radians. A half revolution around a circle corresponds to 180 degrees or pi radians. So a quarter revolution around a circle corresponds to 90 degrees or pi halves radians. So an important skill then that we need to develop is to convert between degrees and radians or radians to degrees. So we need to be able to go back and forth depending on the problem. Okay? So now let me this is just sort of a visual picture, because I never understood as a student why 2 pi radians. Well, so if this distance here is a radian, so that if that's 1 radian, then that's about 2 radians, and that's about 3 radians. So it doesn't quite make it across. Well, how short is it? Anybody tell me how much further, how many more radian, what fraction of or decimal of a radian would we need to go all the way across to there? Okay, so what did I say a minute ago? 180 degrees is how many radians? Okay, pi. So 3.14. So if this is 1, 2, 3 radians, how short are we? 0.14. Okay, and then if we keep going, okay, this is 4 radians, 5 radians, 6 radians. So how short are we here?
.28,
And how'd you get that?
0.14 plus 0.14.
Right. So because all the way around is 2 pi. So that's a little bit more than 6. So it's 6.28 something. So great job. Okay. Great job. All right. Okay, so visually, this is just something that we're going to come back to later, but I just want you to kind of see what the different angles and radians look like. Okay, so let's start down here. So 2 pi is all the way around the circle. Pi is half. All right, it's not a pokeball. It's pi radians. Okay. So pi halves is 90 degrees. And then we have pi thirds, pi fourths, and pi sixths. Okay, so that's kind of what they look like. Now, we'll also, there's some of these angles that as we practice, then I'm going to want you to learn. Okay? It will help you out, but you don't need to worry about writing this now. I just want you to see it. Okay, so the 0 degrees is the same as 0 radians. Okay, 90 degrees is pi halves radians. 180 degrees is pi radians. 270 degrees is 3 pi halves radians, and then going back 360 degrees is 2 pi radians. And so we're all the way around the circle. Okay, so let's say if I had an angle of 11 pi eighths. How would you figure out what quadrant we're in? Okay, if we go back, remember the quadrants go 1, 2, 3, 4. Well, the way you figure it out is you say, well, is this bigger than pi or less than pi? So is 11 eighths bigger than 1 or less than 1?
It's bigger.
Yeah, a little bit bigger. So then this is a little bit bigger than pi. So that means this is going to be in quadrant 3. Okay? Because pi radians would be straight across. So 11 eighths pi is just a little bit more than pi. Okay? All right, so pi fourths, what quadrant would that be in? Yeah, quadrant 1. Quadrant 1. Because pi halves is a 90-degree angle, so pi fourths is less than that. Okay? All right. So now let's get back to the notes here. Conversion formulas. Okay? So when we're in degrees and we want to convert to radians, we multiply by pi radians over 180 degrees. And then the degrees will cancel, and so our answer will be in radians. If we're converting from radians to degrees, then we multiply by 180 degrees over pi radians. So see, that conversion factor is the same. It's just the order. You multiply whatever you start with, that same unit is on the bottom of your fraction so that it will cancel. Okay, so let's do a couple of these. All right, so let's say I had 40 degrees. I want to convert that to radians. So I take 40 times pi radians over 180 degrees. So this is my conversion formula. Okay, so you kind of need to memorize that. All right, then when you multiply, see the degrees are going to cancel. And so then the pi, you can leave the pi in your answer. And so then really all you need to do is reduce the fraction. 40 over 180, and see 20 will go into each of those. Okay. Now, if, let's see, if we had 18 degrees, again, you multiply by pi radians over 180 degrees. The degrees cancel, and so then you'd end up with pi over 10 radians. All right, so go ahead and do on practice 2, go ahead and do A and B, please. All right, is Madison back?
No.
You know, I will tell you, so both groups, you actually, in the talent class, if they call you out for something like pictures or whatever, you actually have the option of not going and then just go later. Okay? So, just so you know, your principals have agreed to that. Okay? All right, now I forgot what I was doing here. 1, 2, let's see. Oh, this is wheel 5. All right, Serena.
Two-thirds pi rad.
2/3 pi radians. Very good. Okay. So, any questions on that? Now, you can write rad for radians. You can write it out 2 pi thirds. You can also use this little r for radians. Or, and here's the deal, is that if you don't put any units at all, it's assumed to be radians. Okay? Now you might say, well, you know, I'm used to dealing with degrees more. But that's the rule in math. So like if your answer is 30 degrees and you don't put the little degree symbol, then it's assumed that you mean 30 radians, in which case you got the problem wrong. So if it's radians, it's okay to put the units any of these 3 ways or leave it off. But if your answer is degrees, you must put in the degree symbol.
Mr. Strong,
Yes.
I got my answer in a decimal. Is that okay? Or
Okay,
do
so you
prefer-
used your calculator, right?
Yes.
Okay, well, just do it as a fraction. You could do it without a calculator, couldn't you?
Yeah, I could.
But so, because for ones like these, chances are that's what the answer is going to look like. So you got 0.666 pi, right? No. Or did you multiply the pi through? Or what did you get for your answer?
2.094.
Okay, so this is what you're going to do. So let's say you get that and you're taking the first quiz, okay? And you look and none of those are, that's not the answer given. And all the answers are written in fractions, okay? Then what you do is check to see which one matches your answer. So now on your calculator, put in 2 times pi divided by 3. And did you get the same decimal?
Yeah, I did.
So then you would know your answer's right.
Okay then. Thank
Okay?
you.
You bet. So, but usually it's actually easier to leave the pi out of it. So don't multiply by the pi and just simplify 120 over 180 and leave that fraction and you keep the pi out of it. Okay? All right, any other questions on that one? Thank you for that question, by the way. All right, let's go over the next one. Actually, I forgot to do wheel 1. So, Raylan.
I got -7 over 36 pi radians.
-7 over 36 pi radians. Very good. Now, see, if you just, again, I think it's harder here to use the calculator. It's easier just to simplify the fraction. And, I mean, I guess you could use your calculator to do that. But, all right, so any questions on that one? Okay. All right, so now let's come back the other way and say, all right, so let's say we have radians and we want to convert that to degrees. So then what we do is we multiply by 180 over pi. Okay, you got to make sure you're doing it in the right order because, see, you want the radians to cancel with the radians. Okay, now, in fact, what's going to happen is not only will the radians cancel here, but the pi's will as well. And so you just have 180 divided by 5, which is 36. All right, let's look at let's see, do I have another one? Okay. All right, so go ahead and do those last two. Oops. No. All right, Ricky, when you've got it.
Degrees.
Can you take those out?
No. So let's. So it's just 30.
Yeah, he gave you the answer for the other one.
Yeah, that one is 30. I got 30.
Oh, okay. Oh, so for D you have 300?
Yeah.
Okay, let's see if that's right. Yep.
No.
Okay. All right, so 30 for C and 300 degrees for D. So any questions on either of those? Anyone need me to go through it? Okay. All right. Let's see. So is anyone curious as to how to do them on the calculator? Anybody want to know that or care? It's not a whole lot easier, but if somebody wants to know, you want to know? Okay, so let's look at this one. 5 pi radians to degrees. Okay, if we want to convert that. So what you need to do is you need to make sure that whatever your answer is, you're in that mode. So if you want the answer in radians, you need to be in radian mode. This one we want in degrees, so we're in degree mode. Okay? So then we're going to type in 5 pi thirds radians. Now, it's a little tricky, but you have to use parentheses, and I'll show you why in just a second. So you do 5 pi thirds, okay? And now you need to tell it radians. So for radians, that's in the angle menu. So second angle. And then the little r here, number 3, that's radians. So that's 5 pi thirds radians. And you press enter, and boom, there's 300 degrees. Okay? Now, if you leave out the parentheses, then see what happens there is it thinks that it's just 3 radians. So it thinks that it's 5 pi divided by 3 radians. So that's not good. So if you want 5 pi thirds radians, then you type it in like that and make sure you're in degree mode. Okay? Oops. All right. Any questions on that? All right. Okay, next, commonly encountered angles. Now, what we're going to do here is we're going to use the triangles from the two special triangles that you learned in geometry. Now, as we talk about these triangles, the 30, 60, 90 triangle and the 45, 45, 90 triangle, if you did not learn those in geometry, you need to learn those today, okay? Because we're going to build on that. So, we're going to start with the 30, 60, 90 triangle. All right, it says, construct a right triangle having 30 degrees as one of its acute angles. All right, so just right below where it says the hypotenuse is, in that little space, draw this triangle. Okay, so you've got a right triangle. The smallest angle is 30 degrees. Okay, so then the other angle, the other acute angle would be 60 degrees. So you have a 30, 60, 90 triangle. All right, now if you pick one to be the length of your shortest side, and the shortest side is always opposite the smallest angle. So if this side is 1, then you should know the other sides. So this is what I'm saying. If you don't know those, you need to learn this. So the ratio for the hypotenuse is 2, and the other leg is radical 3. So it goes 1, 2, radical 3. So now that's a ratio. So if this smallest side is 10, then it's 10, 20, 10 radical 3. Or 100, 200, 100 radical 3. Okay, so, but that's the ratio for the 30, 60, 90 triangle. Okay, so now see if you can, whatever you remember, okay, for practice 2 or 3, it says do the same with an acute angle of 45 degrees. So draw a right triangle where one of the acute angles is 45 degrees. And I want to see if you remember the ratio of the sides for that. All right, now before we go over that, let me just say that in this book, in trig, sometimes you'll see the 30, 60, 90 triangle, but instead it'll be called the pi 6, pi thirds, pi halves triangle, which is the same thing as 30, 60, 90. Okay, but it'll give you the angles in radians. And so it's still the same ratio, 1, 2, radical 3. It's just the angles might be given in radians. Okay, so on the 40, well, okay, let's, or do you need another minute with that? I guess, yeah, okay. Okay? All right. So if you have a right triangle with the acute angle 45 degrees, what's the measure of the other angle, the third angle?
45.
45. Okay, so 45, 45, 90. All right? And so if you pick one to be the length of one side, what's the length of the other side, of the other leg? Also one. That's right. And how about the length of the hypotenuse?
Radical 2.
Yes, very good. Very good. So it goes 1 radical 2. That's the ratio. So it might be 10, 10, 10 radical 2, or 5, 5, 5 radical 2. But that's the ratio of the sides. So those two triangles you need to memorize. Okay? If you haven't already, you need to memorize those special triangles from geometry because we're going to build on that. Now, once again, we might see that same triangle where the angles are given in radians. So instead of a 45, 45, 90, you might see it as pi fourths, pi fourths, pi halves. And so just know that's the same thing. All right, any questions on either of those triangles? Okay. So these are the ones I showed you just to help you get a visual of it. And so now we've got the same picture only with the angles in both degrees and radians. Okay, so all the way around is 360 degrees or 2 pi. 180 degrees or pi. Pi halves are 90. Pi thirds is 60 degrees. Pi fourths is 45 degrees. Pi 6 is 30 degrees. You don't really need to worry about writing all this down because we'll get it again. Again, I'm just trying to help you get a visual of what's going on here. Okay? All right. Well, I think that's a good place to stop. So we're on part 4, arc length and angular speed. So we'll pick it up from there. As far as the practice problems, I would recommend you start working on some of these, just getting some practice. It's just those problems at the very end we won't get to. So anyway, you guys will pick it up from there on Monday. Have a great weekend. I'm glad to have you back. Sayonara.